Yesterday we began looking at slope fields as a visual representation of our differential equations. So a couple of things to remember. Remember that our slope fields are going to be pictures of the slopes or solutions to a differential equation. Something that's important to remember is that solutions must be functions. We're going to pick points and evaluate and then draw the slope. And then here were a couple of the key slopes that we tend to want to look for. If our slope is 0, we have a horizontal line. If our slope is undefined, we have a vertical line. If our slope is positive, we're going to be increasing. If our slope is negative, we're going to be decreasing. So the first one that we looked at was dy over dx equals 2x. It's pretty basic because we don't have a y to plug in as well. On our second one that we looked at, now we have x plus y. So again, we knew that as we're going diagonal here, these are all going to have a slope of 0. So on our next one that we look at, again, we're just sketching the slope field for the following equation, dy over dx equals x over y. The biggest difference for this one is notice that whenever y equals 0, we're going to be undefined. Whenever x equals 0, we'll have a slope of 0. But something important to remember is that undefined always trumps being 0. So if x and y are both 0, so like at our origin, it's going to be undefined because we would have 0 over 0, which is still an undefined statement. So for this one, we would end up with something like this. So we have vertical lines all along our x-axis because that's where y would equal 0. Other than the origin, we have horizontal lines on our y-axis. Notice that we're going to be 1 whenever our x and y are equal. And will be -1 when they have the same value, but one of them is negative. And then it's similar to the last one that we looked at as far as notice that if we're 1 for x and then 2 for y, we'd be at 1/2, so we're not quite as steep. And then when we're 2 and 2, we would be 1, so we get a little bit steeper. Something important to point out is that if I asked you to draw a particular solution, so let's say this time we wanted to draw a particular solution through -1, 1. So notice that that's this point right here. So notice that it's a mostly straight line. As we come to the left, we're increasing. It's going to go on forever. But once we hit this 0, 0 spot, again, remember everything is undefined here. So this will also be undefined. And so that's where our solution has to stop. Because remember that our solutions have to be functions. So if we wanted to say go through the point 2, 1 to draw a particular solution, again, remember we're just picking a point and we're trying to draw what that slope would look like through that point. Again, remember that solutions to differential equations are going to be equations, and so that's why when we draw our picture, it's not just a singular point, it's going to be a function or graph of an equation because I have a differential equation. And so my answer is not just going to be one number, it's going to be a graph of an entire function. So here, notice that we're going up and kind of curves over, following again the path that my slope lines are creating. And then we're going to get closer and closer to being vertical. But then once we reach the x-axis again, it would have to be undefined. Now, if I look at the bottom, notice that if I say I wanted to go through one of the points down here, so notice that over here we have negative slopes, over here we have positive slopes, and then here we would have to have a slope of 0. So hopefully we can kind of see that if I'm below my x-axis, I'm going to have a nicer shape than we did above. It's going to create a parabola-like shape. So that's what one of mine would be below my x-axis. So let's look at another one. So here, my only difference is this time we've thrown a negative in front, so we're still going to be undefined. When y is 0, we're still going to be 0. When x is 0, but basically we're going to be flipped down. So in our first quadrant, we would be negative. In our second quadrant, we would be positive. In our third quadrant, we would be negative, and in our fourth quadrant, we would also be positive. So it's going to look similar, but slightly different. So again, notice along my x-axis, we are undefined. Along my y-axis, other than at 0, 0, we're 0. Again, notice that like when my x and y are the same, it's going to be either 1 or -1. But because of the negative thrown out, so this time when I'm at 1 and 1, I'm going to be -1. When I'm at 1, 2, I'm at -1/2, and kind of so forth. So hopefully we can kind of see, looking at it, we would get kind of almost semicircle shapes if we were to draw them, but they would have to stop at my x-axis. Again, because remember, it's undefined here, it would have to stop here. And then the other reason is because remember, it has to be a function, so I couldn't draw the full circle because then that's no longer a function. So now we're looking at 3 over x. So again, notice that I don't have a y this time, so my values are just going to be dependent on x. We can also think about, well, we know how to integrate that. It would be 3 times the natural log of x. And so we should end up with slope fields that would give us different graphs of natural logs of x's. When x is going to be 0, again, we're going to be undefined. When we are to the right of our x-axis, we're going to be positive. When we're to the left of our x-axis, we're going to be negative. Yeah, so if we were to graph our slope field here, it would look something like this. So again, notice that if I take a point, so let's say 0, 1, notice that as I come through this point, we're kind of going to come over to the right. And then as I come over to the left, I'm going to get closer and closer and closer to being a vertical line because we're going to have an asymptote there, which makes sense because, again, if we were to graph the answer to this, so I'm not graphing 3 over x, I'm graphing the answer to this, which would be, my slopes are going to be a natural log function, which makes sense because that's kind of similar to what my natural log function looks like. Okay, here's our slope field of what x times y would look like at anywhere along my x-axis, anywhere along my y-axis. We're going to be 0. We're positive in my first quadrant, negative in my second, positive in our third, and negative in the fourth. And then this one's slightly different because this one is dependent on y this time instead. So whereas remember before when our equation just had an x in it, it had the same slope in each vertical line that we had. This one's going to have exactly the same slope in each horizontal line that we have because we're only plugging in y's, and so each time like y is going to be 2 no matter where I am along this part of the graph, and so all of these slope lines will be the same. And then when we are at our x-axis, obviously y is 0, and so we're undefined for all of those. And there's our homework. Again, remember, if we have any questions on the notes or the homework or the FRQ, please reach out, either email or send me a Canvas message.